Chapter 4 deals with this idea of iteration. That means that we might have code that repeats itself. So today we're going to learn about a while loop. This is another conditional statement. It's actually very, very similar to an if statement. In an if statement, we choose whether or not to run a piece of code. So we say that an if statement can change the flow of the control because it might allow a piece of code to run or it might not. So we don't have just that top to bottom execution of every statement. With an if statement, sometimes there's lines of code that we actually end up skipping. Very similar for a while loop. We could end up skipping some code or we could end up running it. The difference is in a while loop, we might end up running it more than one time. So the code might run 0 times, it might run once, or it could run twice, 3 times, 4 times, whatever. So we call that iteration, this idea of repeating. So I've got a real basic loop here. I've started with x equal to 10, and I'm going to run my while loop while x is not equal to 9. This iterative process is going to run while true. So as long as we see a true Boolean condition here, it's going to execute these two statements that I have given control to. Okay, and I just like with an if statement, I could put as many statements in here as I wanted. Just like with an if statement, if you don't put braces, then it's only going to attach to one line, just to the next semicolon. There is no else to attach to a while. All right. As soon as this condition becomes false, then we're going to leave the control of the while loop, which means we would go just past that closing brace, and then we would execute this line of code. We will not execute this line of code, okay, until we have left the control of the while. We're going to remain in control of the while as long as this statement is true. Now, I initialized x to 10. Since 10 doesn't equal 9, that's true. So I will enter the while loop. I don't know how many times it's going to run because I'm generating random numbers, okay, from 1 to 10. Until I actually generate a 9, it's going to continue to run. So every time we run this, potentially we could get a completely different result. So let's just see what happens. The first time, it only took me 3 tries to get a 9. Okay, so I just went 4, 1, 9, and then it quit. If I try that again, I probably won't get 4, 1, 9 this time. We'll probably get something different. Okay, so this time it took a few more iterations for me. Again, that code segment, the way that I have it structured, is going to run over and over and over until I get a 9. If I change this word while to say if, now it doesn't even matter like what random number I generate. This piece of code is only going to run once. So it could generate a 9, but it might not. Like this time it generated a 7, and in an if statement, you can only run the code once anyway. So we didn't have to like wait until we got that 9. And so it kept going. All right. Sorry, so it just went once is what I meant to say. All right. If I change this back to the word while, okay, then again, now it might run once. I might get a 9 the first try. It might run 50 times. You know, it's really just kind of random. We don't know when that 9 is going to get generated. So this took, a few more tries to finally generate that 9 from my random number generator. You got to be careful when you write a loop. Okay, so sometimes you might do something on accident. Like for example, you could create a loop that might run an infinite number of times, might not run once. So notice here it says that these loops, when the expression is true, the loop body is executed. This continues until we get a false. Okay, that's what was happening with us. When 9 equaled 9, that's how I got a false condition. In the while loop above, what is the last number printed? Is it always? Well, yeah, hopefully you've noticed every time I've run it, it's always quit when it got a 9. So every single time I got a 9 is when it quit. So yes, it was always quitting on the 9. Remember right here when I asked about the if, it only ran once, no matter what number it generated. I think it generated a 7 for us. But if it's a while loop, it's going to run every time until it hits that 9 due to how I wrote my code. So this one might run twice. It might run 30 times. Okay, again, we don't really know, but notice that the last number out was a 9, because once I got x initialized to 9, to say 9 doesn't equal 9 is false, and that's how I got out of the control of the loop. Sometimes a loop is considered infinite. This means that it would never end. So for example, there's quite a few ways that I could make an infinite loop. So I've given you a few ideas here how we could change the Boolean condition. Try to put something in there that's always going to be true. Now, remember, for me, I'm generating random numbers for 1 to 10. So what if I put a condition here that said something like greater than 0? Every time x gets assigned a new value, it's going to be greater than 0. 10's greater than 0. So like this loop would just run forever now. We'll see the console area eventually start to fill up with numbers here that are going to be printed. And yeah, we could just let this run. I don't know. Eventually, like your stack memory would crash. Like it only allots so much memory, but I don't know how long that's going to take. And I don't really feel like sitting around to find out. But that's what we call an infinite loop. Okay, you can in Replit, you can press stop to break out of that loop. And you know, there's other things I could have done here. Like for example, what if I had said, you know, x, you know, doesn't equal 13 or something? Well, we were never going to generate a 13. I could generate a 9. That's why it was quitting on a 9. I could generate a 7 or a 1 or something from 1 to 10. But if you told me, like, as long as we don't get 13, well, again, this would just be an infinite loop. It would just run forever and forever and forever, and eventually we'd have to stop it. Okay, so another thing that we kind of sometimes might do, not really on purpose, if we knew the value, but maybe if we were generating values at random or something, sometimes, you know, we might write a while loop that wouldn't even run once. So just like if an if statement is false, if your initial condition is false, then it wouldn't ever run. So I mean, I just have to put in any condition here that's initially false. Remember, x is initially 10. So if I said something like x is less than 10, that's initially false. So we're actually not even going to enter the loop. We're never going to print the value of x. And so notice that it never even ran the loop one time. Okay, earlier, remember when I made it an if statement, it still ran it once because I had it at x not equal to 9. It just didn't have to keep repeating, okay? And I could have, the same thing would happen here. Even if I made this an if, it would actually perform the exact same way. Remember, ifs and whiles are actually very, very similar. They're both going to run if their Boolean condition is true, and they're not going to run if it's false. The difference is a while loop is going to repeat. So it's not going to run just once for being true, like an if statement. It's going to run potentially an infinite number of times. Okay. And then if we come down here, let's see what else we have. Executing a return statement inside an iteration will halt it. So just like we've seen before with returns, it would actually just kind of kick you out and end that process. Okay. So we could write like a little sub method to display that. And then also there's multiple algorithms that we're expected to cover with you throughout the year. We've already done one of these. This first one here actually doesn't really have anything to do with loops. Like if I want to know if one integer is evenly divisible by another integer, all I have to do is just run a modulus. So we've been doing that before. Like if I want to know if a number is divisible by 5, I'll ask if its modulus with 5 is 0. And I can do that in an if statement, okay? So that one we've done before. If I want to know the frequency some criterion is met, this is a typical counter loop. We're going to write 100 of these probably before the year's over. But I think I'll wait till we get a little bit further, maybe learn about a for loop, and then we'll talk about that some more. Minimum and maximum, we'll probably try some of these next week, although it'll make a little bit more sense when we learn about arrays. And same with like sum, average, or mode. We can practice that stuff now, although it'll make a little more sense when we get to arrays and other types of things that can hold on to multiple values at once. And then the one we're going to try today is using a while loop is a nice way to identify individual digits of a number. And so this is kind of like an expected algorithm that you're supposed to know. So I've got this thing generating right now a random number. I don't know if you've noticed, every time it comes up with some different big number, okay, it could go all the way from like, 0 to 2.4 billion, whatever the max value of integer is. We don't really know what it's going to say. but it's typically going to be a pretty large number. And I've printed it here. And I want to write a loop that could print each digit of rand individually, one digit per line, starting with the ones digit. Okay, so that would be like starting on the right side, like the 8, in other words, in this random number. But next time I'll probably get a different random number. All right, so there's a few ways that we could do this. And this is again, this is like an expected algorithm. This is a kind of a standard algorithm that you're expected to know if you wanted to like isolate the digits of a number. So for example here, what we could do is we could run this while random is greater than 0. Okay, so as long as we don't get 0, then we'll continue to run this, and we'll see why in a minute. Imagine, I don't know if you've ever taken like a calculator, put a big number in, and you hit divide by 10. Some calculators let you keep hitting enter, and it'll keep dividing by 10. And if you do that enough times, eventually the number becomes 0. And we're going to do essentially the same thing here. So what I'm going to do is I'm going to write a print statement. And what it's going to do is I'm going to print the last digit of the number. We've done this before. We've done it with the modulo 10. So when you divide a number by 10, sometimes you get a remainder. If you get a remainder of 3 or 7 or 8, that's whatever the last digit was. So like the random number on my console right now, if I did modulo 10, would be 8. So this would actually print the last digit of the number. Okay, and then what I'm going to do is I'm going to take the last number and I'm going to divide it and then reassign it by 10. And what that's going to do is that's essentially going to chop off the last digit. Okay, on a calculator, if I divided that number by 10, it would change it to end in 0.8. But in Java, remember, when we divide by 10 and we have integers, there is no 0.8. It just truncates it. So essentially, it throws away that last digit. If I keep doing that, then I'll throw away the second to last digit, then the third to last, fourth to last, fifth to last. Eventually, I'll get all the way down. There won't be any digits left, and I will reach 0. At the moment that I reach 0, my loop will kick me out. Okay, so let's see what happens here when we try this. It's going to make a random number. We don't really know what it is, but this random number, if you look at its digits from right to left, I actually isolated each one. So first the 0, then the 2, then the 3, and so on, all the way down until that final 1. Another way to think of this is like we could make an algorithm add up all the digits of that value. So like instead of printing each individual digit, I could add up to my sum, okay, whatever that last digit was. And then I could print that final sum. This is another kind of common algorithm. So take all the digits and let's display them, or in this case, instead of displaying them, let's go ahead and add them all up. Let's see, what is the sum of each individual digit. Notice that I'm not using like substring or something. Why am I not using substring? Well, this isn't a string, so I can't break it up as a substring of itself. So this is kind of a nice workaround when you're dealing with a number. You can still isolate its digits with this kind of mod 10 divide by 10 trick. So I'm saying if you add up 2 plus 2, that's 4, 7 and 7, that's 18, another 4 is 22, 6 is 28, plus 5 is 33. That's how I got 33. If I run it again, I'll get something different more than likely, okay? But this little algorithm here, very useful when you want to isolate the individual digits of a number. Just keep taking that modulo 10 divide by 10 over and over. You'll see each digit, and then you'll throw it away. You could print it. You could add it to a sum. You could ask if it was a certain number. So maybe for example, I want to print true if the digit 7 appears somewhere in the number, okay? I could track and see what I need.